In this instructional video, we're going to discuss what is called synthetic division, or what I like to call it is the shortcut for long division. Now, you can't always use synthetic division, so that's the catch. Long division always works when you're dividing polynomials. Synthetic division works, let's say if you have a polynomial, we'll call it P of x in this form, where you have the polynomial divided by, let's say, x minus some constant number c. So notice the x has to be to the first power and then minus the constant number c. So what I want to do when I teach this is show you the relationship between long division and synthetic division. And the beauty of synthetic division, I mean, it's a major shortcut. If you can just multiply and add, you can do synthetic division. So let's say you've got a polynomial in this form. Let's say we're taking the polynomial x squared minus 14x plus 25, and we're going to divide that by x minus 2. All right, now first I'm just going to go ahead and do it the long way. So I'll come over here and put the bottom into the top, and hopefully you've watched all of those long division instructional videos and you practice some long division, so you've gone through these steps. And if not, you may want to go back and look at that first, or this may be a little confusing. All right, so we're going to take the first term x, divide it into x squared. X goes into x squared, dividing first term into first term x times. Step 2, when long dividing, multiply the x by the x minus 2, and that'll give us x squared minus 2x, which goes underneath here. So step 2 done. Step 3, subtract, and you know the old saying there, draw the line, boldly change the signs. So the x squares go out, you know you're doing it right. Combining like terms on the x's gives us minus 12x. Bring down the 25 here, and we're going to keep going then. Now we're going to take the x and divide it into minus 12x. So I'm moving a little quicker than I moved on some of these other ones here. X goes into minus 12x minus 12 times. Multiply. You'll get minus 12x plus 24. Watch those signs. Draw the line, boldly change the signs, and I mean boldly wipe out this plus over here, and we have a remainder of 1. And remember, in the long division section, we wrote that as plus 1 over x minus 2. All right, now let's do it the synthetic way, the shortcut, when we can get away with it. And I'm just going to come over here, and I'm going to write kind of a division symbol upside down here. And I'm going to go ahead and put in 1, negative 14, and 25. Now notice here, these are the coefficients in descending order. So there's 1x squared, there's minus 14x, and there's 25. So this is, I'm going to write and abbreviate here, the coefficients of the polynomial P of x, and that's the top part I labeled there, in descending order. Now, what is the constant number? Well, if you've got x minus c, and you look across here to this x minus 2, what number must c be, young? And what you should see, do you get it? What should you see? I'll stop it. Is that c would be the number 2. Now, how I get students to remember this sometimes is I just tell them whatever is after x there, just take the opposite and stick it there. Now, I know what some of you are thinking, Young, why would you do this? I mean, this seems kind of strange here. Now, let me show you something kind of cool. All right, now we're going to just now, like I said, if you can multiply and add, you can use synthetic division. So the first step, whenever you synthetically divide, is bring down this first number here, 1. Okay, and I'm going to use some pretty colors, you know me. Now we're going to multiply whatever is in this bottom row here times the 2. So 2 times 1 is 2, and that goes up in here. So multiply. Now, whatever's in here, we're going to add and bring down. Now, if you don't get it on this first example, don't panic. You know, Young, we're going to do lots of examples in synthetic division, and you're going to thank me before we're done. You're going to say, oh, wow, man, I wouldn't even want to try that one the long way. We'll do it synthetically. All right, what's negative 14 plus 2? Well, that would be a negative 12. since that comes down, we're going to multiply negative 12 times 2, which would be negative 24. Add, bring that down. Now, what I like to do is to put a little bar here as well. Now, what that does is that last number, whenever you get it, will always be the remainder if the polynomial has one. All right, now in orange, let's look at what we have left here. We have 1 minus 12 and 1. Notice our answer when we long divided this. I'm doing it in orange here. We had 1 minus 12 and 1. Isn't colors nice? So what you're getting, folks, is when you synthetically divide, these bottom numbers are the answers in descending order. I'm going to write that. Answer in descending order. Okay. Now notice also, if we were to divide x into x squared, that very first step when we did it the long way, that 1 is always 1 power less than what you started with way up here. It's always 1 power less than that. So remember that. I mean, we're going to do, like I said, several more here, and that will give us x to the first minus 12 plus 1 over x minus 2. All right, so there's our first example of synthetic division. Now, I know what y'all are saying. Now, Young, why would I ever want to do it that way? It seems very difficult to do it that way. Well, let's just look at the next example here. Let me clear this one off. And let's take a polynomial 2x to the 4th power minus 13x to the 3rd power plus 16x squared. Some of you are going, no, stop it, Young, stop. Minus 9x plus 20, all divided by x minus 5. So this is one, thank heavens, we can do synthetically, because we've got that some polynomial in terms of x divided by x minus some constant number. All right, so just like the last example, can you imagine trying to do this one the long way? I mean, folks, we will be here a while, and I don't even think I have room on the whiteboard. I mean, I might have to make 2 or 3 whiteboards to finish this one here. So what we're going to do is show you how valuable that shortcut is. So we're just going to take an upside down division bar, and we're going to go through a few more of these and make sure you feel good. And we are going to write the coefficients of this polynomial, which I'll circle in green here, in descending order. Now notice they didn't skip any powers here. I think the next one we do, we'll skip some powers and show you to be careful, because you can't skip powers. You have to make sure you get them all. All right, so we're going to say the coefficients would be 2, negative 13, 16, negative 9, and positive 20. And we'll put our bar here because we know this last number, when we start multiplying and adding, will be the remainder. All right, now what is the C number? Can you see the C number in the bottom? What kind of 5 is it going to be, positive or negative? This is where students sometimes will screw this up. Well, it would have to be a positive 5 to fit that mold. So in other words, if I were to take some number and plug it in for C here, it would have to be just 5. Do y'all see that? Do you see? All right, now watch how fast we can do this. If we can just multiply and add, now remember, always bring this first number down. Okay, multiply 5 times 2. Okay, so these numbers here in the bottom row get multiplied. Now where do you put the 10? Right up here. Add. Negative 3. Multiply. Where's it go? Negative 15. Here. Add. 1. Multiply. 5. Where's it go? So Young, I'll tell you where it goes, where to stick it. All right, 5. Add. Negative 4. Multiply. Negative 20. Add. 0. So this has no remainder. All right, so we know it goes in there evenly. Now, so we have taken, and I'll do it in green again, the coefficients, and I'm going to abbreviate coefficients, of the polynomial p of x, divided it by that constant number, and these numbers down here represent the answers in descending order. Now remember, I'm going to go ahead and circle this in orange again up here. When you were to take the x to the fourth and divide it by this x initially, it's always one power less. See, so this 2 right here, if you took x into 2x to the fourth, and I'll just circle that whole thing. If you were doing it the long way, and thank heavens we didn't, this 2 would be 2x to the what power? X into x to the fourth third. And then the rest just falls in order. You'll love this. Watch this. Minus 3x squared plus x minus 4. No remainder, done. Now, I know some of you going, well, that seems pretty cool. Yeah, that seems kind of nice. So, okay. Now, we're going to do one more example just to make sure y'all have this. Let me clear it there so some of you are absorbing. And the beauty of this is you can go back and watch it as many times as you want to. All right, one last one, and we'll call this video done, and hopefully I'll be able to turn you loose, and you can go crazy on it. All right, now here's one written kind of a funky way. They've got 2x to the third power. You might see it written this way. Minus 6x squared minus 4. So they write this trinomial, and then they divide it this way by x minus 4. But we do have the polynomial p of x divided by x minus some number here. I tell you, let's make this an x plus 4, just so we have a little fun on this. All right, so we do have some polynomial here divided by x minus some constant number. Now, I'm just doing this to be mean on this one, all right? Young Mitch is mean sometimes. So again, let me make my upside down division here. This one's got all the tricks and turns you can have here. Now notice we've got 2x to the third minus 6x squared, but then they skip a power in here and they go to the minus 4. There is really, just like long division, you have to put in the 0x to the first power plus 0x, or if you don't, things don't line up, even in synthetic division. So if you don't do that 0, oh, it's trouble. So we're just going to put 2 minus 6, 0, and 4. And then we'll put our bar here. Now, what number is the constant out here? In order to get a plus 4 here, C must be what number on the outside? A minus 4. See, so here's again where students miss this. It's the only way you can miss this. If that's a plus 4, and this is in this form, x minus c, do y'all see again? Got to stop it. That you would have to have x minus a negative 4. So that's the number that goes out front. So I always just again say, if you have a question or concern with this, just take the opposite if it's in this polynomial form here and stick it out front. And once again, now multiply, add. We'll knock this thing out and we'll call this video done here. So bring down the 2, multiply, negative 8, add, negative 14. Multiply, 14 times, negative 14 times negative 4 is positive 56. Oh, they're trying to throw us some nasty numbers. Now, add, that's the easy part, 56. I can do that plus 0 pretty good. Multiply, now I might have to come over here on the side of my paper, use my calculator or something here. 56 times negative 4, 24. 5 times 4 is 20. I got negative 224. Okay. I didn't promise you a rose garden here. Add 4, positive 4, negative 224 is a minus 220. And there's your answer in descending order. Now, do y'all remember this trick here? I just want to see. That 2 is 2x to what power? And you should, again, think about it. If I were going to do this the long way, that would be x to the third divided by x in orange here. So this would always be 1 power less than this if you got the lesson, 2x squared. And then the rest just falls right down the line. Y'all ready? Here we go. Minus 14x plus 56. Now, how do we write the remainder? Well, we put minus 220 over what we're dividing by, x plus 4, just like the long way. So a quick look at the shortcut for long division called synthetic division. Try a few on your own, and this is Professor Bob Young signing off. Have a great one.